Something that is very useful for Chapter 3 is sort of a summary of the formulas that you find in Chapter 3. So we'll write them out here for you, and I would like you to copy them down. So we have standard form, and we've mentioned this, ax plus by equals c. Slope, intercept, which is y equals mx plus b. Now, we often use these numbers as reference. So Formula 1, Formula 2, Formula 3 is the slope formula. And following this, we have Formula 4, which is called the point slope form. And that's y minus y sub 1 equals m times x minus x sub 1. And one I like to throw in here is this one. We call it Formula 5. Y equals b, and 6, which is x equals a. Now, these are modifications of standard form, but here there is no x, and here there is no y, because there's 0. And an example of this one would be, let's say, y equals 3, and the graph of that would be a horizontal line going through 3. And as an addition, we'd say the slope of any graph in this form, y equals b, is 0. And for this one, again, if we were to graph it, and an example of it would be x equals 2, let's say. This is going to be a vertical line going through 2. And also, let's write it over here somewhere, the slope of any vertical line is undefined. So these are some of the basic formula that we will be dealing with in Chapter 3. Now, some other things that we're naming and giving numbers to is, for instance, 7. Now, it's not so much a formula as a definition. If we have slope of an equation, that is the first slope, m sub 1, and that equals the slope of a second equation, which we'll call m sub 2, but the y-intercepts do not equal each other, then we say the lines are parallel. So we'll be getting to this later in Chapter 3, where we're looking at lines, and you'll be asked, are they parallel, are they perpendicular, or neither? And what we do is we set them up in this form, slope-intercept, where we solve for the letter y, and we compare the m's. Here, if the m's are equal, but the y-intercepts do not equal, then the lines are parallel. And another definition we'll call number 8. We have, if the slope of the first equation over here and you multiply it by the slope of the second equation, and the product of multiplying the slopes is a -1, such as 1/2 times a -2/1. We multiply that, in a sense, the negative reciprocal of the other, then the product is -1. Well, in these cases, the lines are perpendicular, and that's the symbol we use for perpendicular. And to wind this up a little bit, in number 9, if we're plotting, let's say, y equals, y is greater than or equal to 2x plus 2, and then we'll do number 10 here. Y is less than the same thing, 2x plus 2. A couple of things are going on here. So if we make a quick graph, sketch it, our y-intercept is 2. We put a dot at 2. Our slope is 2/1. So we would go over 1 and then up 2. And that'll be our second point here. And since this is an inequality, and there's also an equal sign as part of that inequality, what choice do we use? Well, we're going to use a solid line. And now we have to determine, where do we shade this line? Well, here we're giving you the hint that if a positive y is greater, we shade it above the line. And now doing this one, again, our slope, well, our y-intercept first, over 1, up 2. Now, when we have the inequality sign without the equal sign, instead of drawing a solid line as we did here, we're going to draw a dotted line. That indicates the points along this line are not included in the set. And here we have y is less than. Whenever a positive y is less than, we shade under the line. Now, we'll be using other techniques in our lecture to go over a lot of these in details, because these are many sections. But again, having these formulas available and definitions for Chapter 3, a very, very useful thing. I would strongly advise, again, you're copying this and including it in your notes.